Saxon's Calculus, Lesson 24, is about infinity as a limit and then undefined limits. So when we are dealing with infinity being our limit, that is exactly as it sounds. When I test it, I find that I am going forever in either the positive direction or the negative direction. So here in example 1, they're saying to find the limit of x going to the infinity. Now this one did not clarify a sign, positive or negative. When that happens, you must test it from both directions. If you get a mismatched answer, like something completely different for the positives and the negatives, you don't really have a solution. If, however, it comes out the same thing, then whatever that is the limit you need. So in this example, then they give us 4x squared plus x plus 6 all over 3x squared plus 1. Now, up to this point, we've been taught if we can plug in the infinity to the denominator and get a specific answer that's not creating a problem with 0, then I just do that and plug it in. If that creates a problem, then I factor it if I can and cancel things out to get rid of the denominator part, hopefully, and then unlock that problem and then plug in the infinity and solve. But because I'm plugging in infinity, and also because I can't factor this stuff, I need a new method for dealing with it. And so what you do is you take and you look at the denominator and you find whatever is in this spot, or if they've written it backwards, whatever is the highest exponent value, and you divide all parts of the problem by that x squared, not its coefficient, not the entire term, just the x squared. So this one divides by x squared, this one divides by x squared, this divides by x squared, and this one divides by x squared. So when I do that, the x squareds here cancel, and I'm left with 4 plus x over, oh, wait a minute, x over x squared, that's going to cancel and become 1 over x because I'm killing an x off of both, plus 6 over x squared, and then the x squareds cancel, leaving me 3 plus 1 over x squared. Okay, so now let's think about what happens here. If I plug infinity, so the larger that my numbers go, 1,000,000, 1 over 1,000,000 squared, that's even bigger. 1 over that gets really close to 0. It's 0.00000 whatever. So everywhere there is a fraction with the x squared or an x piece in the denominator, it's going to approach 0 and therefore drop off. So I can now ignore all of those because the same thing happens with all of them. They all get so close to 0 that we're ignoring them, because remember, the limit isn't exact, it's where you're approaching to. So ultimately I am approaching 2 4/3, whether I'm coming out of the positives or the negatives. In example 2, it says to evaluate the limit x heading to infinity, negative infinity, and it gives us x cubed plus 6x over 8x squared plus 5x. Again, I might be able to factor an x out of these and cancel that off, but since I'm plugging in the negative infinity anyway, I'm just going to go ahead and do what we did the last time and divide everything off by x squared. So x cubed over x squared just leaves me an x, and then 6 over, and the 1x canceled with 1, so over 6x. The x squareds canceled and left me 8, and then plus 5, and x over x squared loses the x and just keeps an x. All right, so now when I plug in negative, I still approach 0 here and here, but this one does not drop off. So negative, so I have to picture very large negative numbers dividing by an 8. Well, that would still be a negative number, and it could be any number. And does it matter okay, the closer to 0 that I am, like -1, that's still -8. So whether I test a big number or a small number, I always get a negative number of some sort, which makes my limit negative infinity. Now, part B is undefined limits. They are going to be ones where my graph is dealing with an asymptote, and in my equation, I'm dealing with the denominator equaling 0 that I can't resolve. I can't cancel it off and get rid of it. Therefore, I'm getting undefined limits. So in example 3, it says, find the limit of -1 over x plus 3 squared as x approaches -3. So I will graph it in order to see what's happening. So 0 plus 3 is 3, squared is 9, negative something or other. Wait a second. Where is my asymptote? What creates 0 in my denominator? -3. Need to deal with that first. -3 creates an asymptote. Now go back to my 0. 0 gave me a negative something, but it was really tiny. And it was in the negative. So I don't know, I'm gonna guess about here. All right, so I don't know whether I'm curling this way. I'm probably curling this way because it's negative. I feel like my answer should be in the negatives. But I don't have enough information at this point, so I keep plugging in numbers just to see what's going to happen. So let's do a -4. -4 plus 3 is -1, squares to 1. -1 over 1 is -1. So -4 graphs -1. All right, let's do -2. -2 plus 3 is 1. 1 squared is 1. -1 divided by 1 is -1. So that was here. All right, now I feel really confident because that was such a tiny number that I'm bounded by the x-axis, and this is skewing me down. And let's do another one over here so I can get a better feel, because one dot doesn't really make a picture. And then, so that would be 1, 2, 3, 4, 5, -5. -5 plus 3 is -2, squares to 4. -1 divided by 4, so that's a fraction, -4. So that's really tight up here. Okay, so again, I feel like the x-axis is bounding me, and that's going to skew me downward. So now I've graphed it. What is happening as I approach the -3 from the positive side? Oh, plummeting, negative infinity. What's happening when I approach it from the negative side? Oh, plunging, negative infinity. So negative infinity is my boundary because it works from both sides without an issue.